everyone, this is Syma from Science of the Times. Welcome to my short explainer video about an article I saw on the BBC Science website entitled Tiny Creatures Gorge, Get Fat, and Help Fight Global Warming. When I read that headline, I was suitably intrigued. It sounded a bit bizarre and counterintuitive to me that somehow eating a lot and getting fat can help us in the fight against global warming. So I took a look in a bit more detail, and it turns out that the tiny creatures that do this and help us in this way are called zooplankton. These are tiny little creatures that are found on the surface of freshwater habitats. They're pretty ubiquitous, found all over the place in nature where you have freshwater habitats. And actually, it turns out that many of us probably know them because if we've kept aquariums, you can buy them as fish food or food for the healthy, the healthy development of your aquarium from any pet shop. Okay, so probably many of us have encountered zooplankton at some point in our lives. Okay, so how does their feeding help us in the fight against global warming? Let's take a step back and consider what we mean by global warming. Okay, so global warming is something that's been in the news a lot, and quite rightly so, because it's a really important issue that's affecting the entire planet, and something that very much needs addressing. So what is it? So most of you will be aware that in our atmosphere we have a whole bunch of different gases. Some of those gases are known as greenhouse gases, and that name comes from the effect they have, which is very much like a greenhouse. In other words, they can trap heat and prevent it from escaping. And in the case of these gases, because they're in the atmosphere of the Earth, they prevent heat escaping from the surface of the Earth. And if that was all there was, of course, what would then happen would be that the temperature of the Earth would continue to rise as sort of more and more of the heat is trapped by these greenhouse gases. But that doesn't happen, and that's because there's other gases and there's processes in place that remove the greenhouse gases and cycle them and produce other gases. Okay, and so there's a sort of an equilibrium that exists. Okay, so these greenhouse gases are produced, but they're also removed, and other gases are produced, and we get a sort of a cycling of these gases. And what that means is that there's a sort of a normal level of greenhouse gas that can be tolerated in the atmosphere, which allows us to keep the temperature of the Earth fluctuating, but within a certain acceptable range. And we have the temperatures and the weather, the climate, and everything that comes from that, the ecology of the planet as we know it now. The problem comes if there is an alteration in the composition of those gases in terms of the content. If we get more of these greenhouse gases than is normal, that equilibrium is perturbed, and so the effect, the greenhouse gas effect, is amplified, and so the temperature of the Earth rises. Now, a big problem with that. Sorry, the big problem that contributes to that is we get an overproduction of carbon dioxide, predominantly through human activity, such as the burning of fossil fuels. So this means that we get more carbon dioxide in the atmosphere than can be tolerated, or that is is acceptable within this normal processes that we have and this equilibrium. And so what that means is that there's an excess and the greenhouse effect is amplified, and that's what we see now. Unfortunately, slowly but surely, the temperature of the Earth overall is increasing, and that leads to catastrophic effects, or effects that will be catastrophic down the line. For example, we're already seeing melting of the polar ice caps, and those have effects on the fauna and flora of the planet. Okay, so where do these tiny creatures come in? So before we look in before we consider those in detail, it's important to note that the oceans here play a huge role. This excess carbon dioxide that is produced, turns out that 90% of that can be absorbed by our oceans. Okay? And that's really good news for us that we have the oceans, and they can provide us with, if you like, this kind of buffer. They do that largely through these tiny creatures, these zooplankton. Okay, so how does that work? So these zooplankton, They eat tiny plants, which are also found in freshwater habitats, and these are called phytoplankton. And as with all, as with other plants, these plants photosynthesize. So they naturally remove carbon dioxide from the atmosphere and release oxygen. Okay, of course, that's the opposite of what we do. We breathe in oxygen and we release carbon dioxide. And actually, it's this is part of this cycling and equilibrium that exists on the planet. Now, these phytoplankton, as I said, they remove carbon dioxide. Carbon dioxide, as you'll know, is made up, each molecule is made up of one carbon and two oxygens. So the oxygen is released, but the carbon remains within the plant, within the phytoplankton. Now, the zooplankton come along and they gorge and they eat these phytoplankton. So the carbon is then now transferred into the zooplankton. Okay. So the zooplankton now full of all of this carbon that they've gotten from the tiny plants. Okay, that's great. But how does that help us? How do they lock that away? Now, what's central to this is the migration patterns of the zooplankton. So these occur on two different timescales. So they have a daily migration and they also have a seasonal migration. So, and not every single zooplankton does this, of course, but within the zooplankton, there's many different types. They're very diverse range of creatures. And some of them, for example, these copepods have these migration patterns. So daily migration is whereby during the nighttime, the zooplankton are on the surface of the oceans. They will eat the phytoplankton, but then in the daytime, they'll disappear down into the ocean. And they do that to get away from their natural predators. So at the night they eat, they gorge, they get this carbon inside them, they turn it into fat. So that fat is a store of energy, something that a bit like, a battery, they can use that to power themselves later. And then they disappear into the ocean where they can spend the entire day there and they don't need food or anything because they've got this carbon inside them. Okay. And then at night they can move back to the surface and eat some more. So that's the daily migration. But there's also a seasonal migration whereby they really at nighttime come out and gorge and eat as much of this phytoplankton as they possibly can. And what's really cool is on that BBC website, you can actually see images of the zooplankton with the stores of fat inside them. So you can really see that the vast majority of the creature's body is actually made up now of this fat. And it needs that because it's going to go away and hibernate for a season. So it needs a hell of a lot of fat for it to be able to use as energy during that time. And so they go deep into the ocean, sort of between 500 to 2,000 meters down, so really into the depths. And what they do then is during that time, they just burn off this carbon that they've got inside them stored as fat, and they power themselves that way. So they have no need to come back to the surface to eat more because they're just using up these stores. And now what you might think, well, that's great, but when they burn off the fat, they're releasing carbon back in. So how does that help us? They're releasing the carbon again. The way that helps us is all to do with time. Yes, absolutely. When they start to burn up those stores of fat, they do, of course, release carbon, but that carbon can take tens to 100 a year. They can sometimes take a century before it comes back to the surface of the ocean. Okay, so it's locked away for a long time, and it's that time lag that really helps. Okay, so it's a long time before we see that carbon back in the atmosphere as carbon dioxide, and so before it can have that greenhouse effect. And so the more and more zooplankton we have, the more phytoplankton can be eaten, and the more of this carbon we can have locked away deep into the oceans. And it's that sort of it's the seasonal migration, the ability to store away the carbon as fat, and then the slow release through the oceans, the absolute sort of as I said, sometimes centuries it can take for it to come back to the surface, that plays a pivotal role and a really important role for locking away that carbon from the atmosphere. It's not forever, but it's for a long time, and that helps to re-establish this equilibrium that helps us to keep the planet in these acceptable or normal temperature ranges. Okay, folks, so I hope that's helped to explain how zooplankton can eat a lot, get fat, and help us in the fight against global warming. I refer you to the BBC website for more details and links, and I'll put some more links if you want to read more about this with this video. Take care.